Good morning, my name is Lauren Ortiz-Hunt, and this is my Model 1 video covering our Week 1 topic, what is sound and how is it made? In order to understand how sound works, it is important to understand what sound is. Sound is a vibration. What does this mean? It means that sound is the result of molecules bumping into each other. And how do these molecules bump into each other? They do it via energy. Energy is a series of molecular movements. So, some sort of catalyst excites the molecules and gets them vibrating. Most often, the catalyst is air or heat. As we discussed in lecture, air is not what creates sound, and sound does not move through the air. Rather, air produces energy, which makes sound, and the sound creates a chain reaction. This is why sound is most often discussed in the form of waves, as energy is continuous. Now that we've covered what sound is, it is important to understand how we receive these sound waves. Sound is produced by transducers. A transducer is something that converts one form of energy into another. So, the vibrating molecules are converted into something audible by a transducer. One example of a transducer we learned about is a piano. Pianos consist of strings and hammers. The strings are all pulled at various tautness and all hold potential energy. And the hammers are poised above the strings, also holding potential energy. The strings are then struck by the hammer, causing a series of vibrations, which is converted into acoustic sound. I decided to identify another transducer in my daily life and learn about how it converted energy into sound. I chose to look into why our blowtorch makes sound and why it can create different pitches, especially when ignited. For this project, I made personal observations as well as used a Stack Exchange physics forum called Why Does Fire Make Noise for my research. So first, I decided to play with the torch. This is just our Coleman blowtorch and it is powered by propane fuel. There are a couple components to it that create fire. First, you turn the knob to open a valve, which releases a stream of propane. Then you can use the ignition here or a lighter because our ignition is out sometimes, which creates a continuous stream of fire. As such, when the blowtorch is producing a steady stream of fire, you can hear it making a humming or whooshing noise. This can be explained by a couple of factors. First, the fire is putting out heat. Heat is energy created by pressure and vibrating molecules. Heat produces sound due to the vibrating molecules and the continuous flow of propane. Here, the propane is our catalyst in a form of potential energy. The knob on the blowtorch serves a similar purpose to the hammers on the piano, and is also a form of potential energy. I then decided to play around with the knob, increasing and decreasing the amount of propane allowed through the valve. In a sense, this would be like playing different keys on the piano. When you turn the knob, you modulate the pitch of the sound emitted from the blowtorch. This is because when I release more propane, it creates more energy and fire. This causes the molecules to vibrate more, making a higher pitch and louder sound. When I turn the knob down, it releases less propane, which produces a lower pitch and a softer sound. So the propane in torch itself is a transducer. The second transducer is my ear in this example, as well as my microphone in my computer. This experiment was interesting as I was able to turn acoustic energy, the propane itself, into electrical energy when I ignited the propane. This amplified the sound because the fire caused the molecules to move more. You go from like the steady stream, a little bit lower pitch sound here, then as soon as you create a sort of electrical energy, you can hear that the pitch increases a lot. In conclusion, my blowtorch is a hands-on example of how sound is produced and manipulated. Thanks for watching!